Hi class, we are now going to be looking at the last section of chapter 20, and this is having to do with corrosion. So when we discuss corrosion, corrosion is the oxidation of metal structures. We know corrosion more as rusting. We're familiar with it in that term. And what it has to usually do with is it occurs more in wet, salty locations and areas that receive a lot of acidic rainfall. So areas that have wet conditions and then they use salt on the streets, that can create a lot of perfect conditions to have oxidation of metals. And when we talk about wet conditions, well, all rain is mildly acidic. I don't know if you ever looked at a pH when we were, in another chemistry where you covered pH. Rain is more acidic than basic, so it already has those conditions in it, which allows the hydronium ions to play a process in this. So any salt that's dissolved in the water on the surface of a metal can act as an electrolyte and help speed up the corrosion. So, so corrosion is undesirable, spontaneous, gradual oxidation of a metal. And it's gradual because if you leave a nail out, it's not going to immediately corrode. You will see it corrode slowly over time. So let's take a look. This picture is not in your book. I'm going to explain it and then I'm going to try to explain it again in a different way. So the reactions that's responsible for the corrosion, if we look at this, iron atoms are on the surface. So here's the iron, okay? And it can undergo oxidation to form Fe2. So we see we have Fe2 here. I know I'm probably not explaining this as well as I would like to. Now, which dissolves in a drop of water. So this is in the water. So it's combining with the water here. The electrons released by the oxidation of the iron are conducted through the metal to a site near the edge of the water drop, where oxygen from the air is reduced by the electrons and combines with H3, so hydronium ions, to form a water molecule. So this is the cathode portion. The site at which the iron is metal is oxidized over here is the anode. And excuse me. Okay, so the site at which the iron metal is being oxidized is the anode. So this is not directly stating which is the cathode and which is the anode, but it causes a small pit to form on the surface of, excuse me, the iron. What ends up the overall product of this rusting, of the corrosion that's formed from the Fe2 that reacts directly with oxygen in the air, is this iron 3 oxide. This is the rust right here. So this is ultimately what ends up happening after all of this happens here. And that's because of the Fe2, that the ionic iron that reacts with oxygen, which will then lead to this rust to deposit at a site nearby, but separate from the anode. So all these have different little, you would think that all this would take place at one section, but it doesn't. This is still raindrops, so this is very small, but they're all separate from each other, which is really actually very interesting that they all have their own separate little sites here. But this is a behavior of electrochemical behavior. So that's why this is attached with an electrochemical, because of the way that there's a cathode, there's an anode, but it is corrosion. And this is very prevalent in wet areas where the pH is acidic. Okay, so let me point out what is happening. So we have iron as a solid, and excuse me, it gets oxidized. So then we have the Fe2 and the 2 electrons. So that's the oxidation reaction. The reduction is we have with the oxygen, and this is not actually like spelled out correctly. It's over here. The oxygen and the water molecules. So these come together and they end up producing this water liquid here. So that's where the reduction, the cathode takes place. Then there's a further redox reaction. And again, this is all spread out. So that's why it's looking kind of interesting. But we deal with the Fe2 again and the water molecules plus the oxygen, and that ends up producing the iron 3 sulfide oxide, and the hydronium, is it hydronium? The hydronium ions. So this is all spread out, but that's the further redox that occurs. So there's an oxidation, reduction, and then a further redox that occurs. Okay, so iron atoms on the surface of the metal, this is kind of repeating exactly what I said. The surface of the metal oxidize and they release electrons. That's the anode. These electrons conducted through the metal to a site near the edge of the water drop, and that is where they reduce molecular oxygen. And that combines with hydronium a proton to form water molecules. The iron atoms oxidize at the anode also react with oxygen to produce iron 3 oxide. That is the rust. Fe2O3 is the rust. And that deposits near, but not on the anode. Corrosion can be prevented by connecting a more active metal, which means something that's easier to oxidize than iron, on the surface of the iron, so that will be oxidized instead of the iron. This more active metal becomes the anode and supplies electrons to reduce any oxidized iron. So because if it is easily oxidized, then those electrons will go to reduce iron so that it prevents that. So you can't have two anodes. One has to be an anode, one has to be the cathode. Or basically one has to be oxidized, one has to be reduced. So if you have something that is more easily oxidized, then that means the iron has to be reduced. And we'll take those electrons, and that's what it means to reduce any oxidized iron. So if there is any iron that has lost its electrons, the electrons can now be supplied back, thus preventing more rust. Okay, and these are, this is just showing the reactions and the cell potential that comes with them. So the reduction of most metal ions lies below oxygen. So if they do, then they are easier to be oxidized by oxygen. So that's a spontaneous reaction. Again, this is more just explaining exactly what I just said. In acidic solutions from gases dissolved in the moisture, the iron 2 migrate through the moisture to the cathodic region where they are further oxidized. This forms rust, and rust is actually a hydrated, and hydrated is that fancy H2O with an N attached to it, which just means it's hydrated. You must have moisture to be present. It has to be present. Water is a reactant. Ion flow is required between the cathodic and anodic regions. Electrolytes promotes rusting because they have ions in them, so they can allow this to go to enhance that current flow, and acids promote rusting. So again, here is another, this is in your book, just showing the different steps of what I was talking about. So this is the one, this is the oxidation portion right here, excuse me. And then here is the reduction portion, and then a further reduction, a further redox equation that occurs. And then here you get the rust. So this is just showing it sideways. But it does actually, if you see, it says cathodic region and anodic region. So this actually explains a little bit more in detail, which is nice. So how can we prevent rust? Well, there is a way to prevent rust or slow down rust. And one of them is having a metal that's easily more oxidized. And that will be oxidized, which then means that the iron will be reduced. If there is any sort of, little imperfections that will start rusting on it. Some of the things you do, well, if you have a car, you paint it. The paint, as long as the paint stays intact, that means that you are preventing from rust occurring. Some metals, such as aluminum, form an oxide that strongly attaches to the metal surface, preventing the rust from the rest of the metal from corroding. So what it does is that some metals like aluminum will actually form an aluminum oxide, and that substance is no longer aluminum, but it's a different substance related to aluminum with an oxide, and that can prevent any further, it's resistant to rusting. So as long as that's covering it, whatever that is, that metal is not going to corrode anymore. Another is to protect a metal to attach it to a more reactive metal that is cheap. So that's a sacrificial electrode. That's where galvanized nails come in, because that metal that is protecting it can corrode down, but it will still protect the iron underneath it. So that's where the sacrifice. You're sacrificing this cheaper metal to not lose the iron that's underneath, and that will oxidize easily. So again, how do we do this? How can we protect the metal from being corroded away? So in this case, for this, we can put something as zinc as the more easily oxidized metal. So this becomes the anode, this is the cathode. So this will come into combination with the environment or the air and be oxidized down. So it'll lose its electrons. However, those electrons will be reduced back into the iron if there is any imperfections. You see where the surface here is interacting with the iron. This can come in and prevent any more rusting from it. So the zinc is kind of taking the hits, but still protecting the iron, and those electrons go right back into the iron if there is any problems with it. So it prevents the corrosion of iron. So this is one way, that's a cathodic protection. So we're protecting the cathode, which is iron now, because if zinc is easily oxidized, then the iron has to be reduced down. And this is the sacrificial anode, where you attach that metal that will be oxidized, and thereby preventing the iron from being oxidized away. So that sacrificial electrode, that's the one that's going to be oxidized away. So in this case, it can be zinc and magnesium are currently more frequently used as sacrificial anodes for an iron structure. So review, corrosion is an electrochemical process in which a metal structure acts as an anode and is oxidized upon exposure to air and mildly acidic conditions. A cathode protection converts the structure of a cathode to prevent corrosion. And the whole thing is just to prevent corrosion.